911 emergency.
I need any unit, sugar fighting now. Just blow.
Port Wentworth, Georgia. February 7, 2008. 7:19 in the evening. 4 minutes after the first explosion, fire crews arrived at the Imperial Sugar refinery. They did not find a burning building. They found total destruction. Concrete floors had collapsed. Brick walls had been blown outward into the rooms where workers were standing. The emergency water system built to stop exactly this had already been destroyed before it could release a single drop. Rescue crews moved through thick black smoke and extreme heat, searching, calling out, listening for responses that were not coming. 14 people died that night. 36 more suffered burns that changed their lives permanently. When investigators arrived, they expected a gas leak, a chemical failure, an electrical fault. What they found was sugar. Ordinary. Every day. The same sugar sitting in a bowl on a kitchen table. The Imperial Sugar refinery had been operating safely for 80 years. Deep beneath the facility ran a basement tunnel housing a large steel conveyor belt that moved raw sugar from 3 enormous storage silos to the packaging floors above. For 80 years, the tunnel was open. Air moved freely. The fine sugar dust the moving belt created simply dispersed into the ventilated space, too thin and scattered to cause any danger. Then, in 2007, management made one decision that changed everything. To protect the sugar from falling debris, they installed tight steel panels fully enclosing the conveyor belt assembly beneath the silos. A sealed metal box running the entire length of the belt. It appeared to be a reasonable quality control solution. It was not. The space inside the new enclosure was 10 times smaller than the open tunnel it replaced. The natural airflow that had kept the system safe for 80 years was now completely blocked. Inside this dark, sealed space, the fine sugar dust the belt produced every single day had nowhere to go. It built up, hour by hour, shift by shift, growing thicker and more concentrated inside the sealed enclosure with every passing day. Fine, dry powder, suspended in trapped air, each microscopic particle surrounded by a small pocket of oxygen. When enough particles pack together closely enough, the mixture does not just burn, it detonates. Management never consulted a safety expert. They never reviewed what the enclosure would do to the air inside it. They signed the approval and moved on. The factory ran this way for months. Every condition needed for a catastrophic explosion was already permanently in place inside that steel enclosure. The only thing missing was a source of heat. The evening of February 7th began with something routine. A blockage in the first silo outlet. Workers opened the access covers and used metal rods to clear the jam from above. Standard procedure, nothing unusual. But while they worked, the second silo directly above the belt kept running. Sugar kept coming. The blockage created a dam. Granulated sugar began spilling violently off the belt and flooding the sealed enclosure below. The dust concentration surged past the point of no return. Deep inside the dark enclosure, invisible to every worker above, a second failure had been building for a long time. One roller bearing supporting the heavy moving belt had been running without adequate lubrication. Metal grinding against metal, generating heat. Slowly. Continuously. With nowhere for that heat to go, the metal surface climbed in temperature. Degree by degree, without stopping. At 360 degrees Celsius, the surface reached the ignition point of sugar dust. The hot metal touched the concentrated dust cloud. The first explosion ruptured the steel enclosure from the inside. The pressure had only one direction to travel: up. It forced through every gap between the basement and the floors above. It shot straight up the vertical shafts connecting the lower level to the packaging rooms at the top of the building. When it hit the upper floors, it did one thing that turned a contained basement event into a building-wide catastrophe. It shook the entire structure. For years, not months, fine sugar dust had been slowly settling on every high surface inside the packaging building, on top of ceiling beams, on top of concrete supports, on top of pipes and cable trays running near the ceiling. Every surface too high to see from the floor and too inconvenient to clean regularly. Nobody had measured it. Nobody had tracked it. Nobody had removed it. It had simply grown there, invisible, ignored, waiting. When the pressure wave shook the building frame, every beam, every support, every pipe vibrated at the same moment. The accumulated dust fell. All of it. At the same time. From every high surface simultaneously, dropping through the air like a thick white cloud descending from the ceiling toward the floor. The advancing fire from below entered the room at the exact moment the falling dust cloud reached ignition density. The building exploded from the inside. Concrete floors broke apart and pushed upward. Brick walls surrounding the exit stairwells collapsed outward into the rooms where workers were trying to escape. The fire suppression pipes ruptured before a single sprinkler activated. Rolling fire advanced through the entire multi-story structure. 14 people died. 36 more were severely burned. Investigators traced every decision back to its origin. What they found was not one catastrophic mistake. It was a chain of small problems that everyone had learned to accept as normal, until the chain broke all at once. The managers who installed the steel enclosure never asked what would happen to the dust inside it. The maintenance teams knew the bearings ran hot. It was recorded in the logs. It was accepted, never fixed. The workers inside that building every single day had never been told that sugar dust at sufficient concentration is classified as an explosive material. They worked surrounded by the fuel for a catastrophic explosion, and they had no idea. The Chemical Safety Board was clear. This was entirely preventable. Every factor that caused it was known, observable, correctable. One sealed space, one ignored accumulation, one bearing that nobody lubricated. In industries that handle hazardous materials, catastrophe does not require extraordinary circumstances. It just takes an ordinary ingredient.